Hi guys, Miss Griffin. We're looking at Unit 11, Skill 3, and we are talking about independence of two events. So here's your essential question. Go ahead and copy that down real quick. How do we determine if two events are independent of one another? So to prove that A is independent of B, we must show that the probability of A given B is equal to the probability of A. Or we could do the opposite of that. Probability of B given A is equal to the probability of B. So we're just going to write a little sentence here that says two events are independent if knowing one event has occurred does not change the probability that the other event has occurred. Okay, so we've got this first example. It says the probability of Jamie going to the movie theater, tomorrow is 0.7. The probability she'll go for a run is 0.4. And if the probability that she'll go to the movies and go for a run is 0.28, determine if the events are independent. So first you want to make a little two-way table so that we can have the probabilities of these two things. So we've got, say, M for movies and M prime for not movies total, and R for run, R for not running, and total. They give us 0.7 for going to the movies. They give us 0.4 for going on a run. And they give us 0.28 for going to a movie and going on a run. So take a minute to fill this in on your own. Okay, so you should have been able to find the blue probabilities just by doing subtractions, knowing that total is always 1.0 for probabilities. And our goal here is to show independence, hopefully. So we want to show that the probability of going to the movies, given that you've gone on a run, is equal to the probability of just going to the movies. So if it equals each other, that means they're independent events. So going to the movies, knowing that you've gone on a run. So looking at my run row and going to the movies. So 0.28 out of 0.40, question mark with an equal sign, to the probability of just going to the movies, which is 0.7. So if I type this into my calculator, 0.28 divided by 0.40, it actually does give me 0.70 equal to 0.70. So we would say yes, the two events are independent because the probability of Jamie going to the movies given that she ran or that she runs is equal to the probability of just going to the movie. Okay, so the whole idea about this probability stuff is, do these two events rely on one another? If we're talking about maybe like going running and the probability of it raining, so Jamie probably wouldn't go running if it were raining, well, those two would be dependent on one another. if these two numbers were not equal. We're going to see one more example on the back, maybe two more examples. So flip it over and we'll see those two questions. All right, so example 2, go ahead and take a minute to read this and start filling out your table. Okay, so maybe you got to this point and you're like a little stuck. So I've got asthma versus not asthma along the top, smoker household versus non-smoker household on the bottom, and I was able to fill out the first three numbers. But then I'm seeing this part here. 464 of them lived in a household or had asthma. So this is where the Venn diagram part's maybe going to come in handy. So we know that asthma is 182. We know that smoker household is 395. We know that there's 937 in total, but our or section, so like this piece plus this piece, is equal to 464. So we want to be able to come up with this and section. And so to do that, remember that we can just add the two totals, A and S, subtract away the or, and then we'll be good. So 182 plus 395, but then subtract away your or. So this gives us 113 for the and section, which gets plopped right here, where the two events occur together. So go ahead and fill in the rest of the table. Okay, so we're asked if the two events, being that a student has asthma and a student is in a household that smokes, are independent of one another. So do they depend on one another? Meaning, does a person with asthma necessarily live in a smoker household? So again, to do this, we need probability of asthma given that you're in a smoking household equal to the probability of asthma. Or we could do the reverse of that, probability of smoker given that you have asthma equals probability of being a smoker. Okay, so in this case, I'm looking at the smoker household column and being in that column as an asthmatic, 113 out of 395. See if that's equal to the probability of being a student with asthma out of the total 937. So when I do this, I should have a question mark here because I'm trying to test to see if they're equal to one another. And I type them in my calculator, I reduce them, or I get decimal values, and in this case, I get 0.286, which is not equal to 0.194. And so therefore, these are not independent. So what we're saying, we're pretty much concluding that there's a probability that if you are living in a smoker household, you are going to likely have asthma. So not independent, since the probability of having asthma given smoker household is not equal to the probability of just having asthma. All right, one more quick example here. Eric's trying to figure out his weekend. There's a 60% chance of rain tomorrow and a 50% chance that Eric's going to do yard work tomorrow. If the probability that doing yard work given that it's raining, so probability of doing yard work given that it's raining is 0.20, 20%, are the events raining tomorrow and doing yard work tomorrow independent? So they tell us the probability of rain is 0.6. Probability of doing yard work is 0.5, sorry. So I want to test to see if the events are independent. So I'm looking to see if probability of yard work given that it's raining is equal to the probability of doing yard work. So we've got 0.20 and 0.50. These are clearly not equal, so therefore these are not independent. because or since the probability of doing yard work is not equal to the probability of doing yard work given that it's raining. I mean, personally, I wouldn't be doing yard work when it's raining, so those two events would definitely be not independent for me, and therefore likely dependent. I would not want to do yard work in the rain. So go ahead and go to your practice problems. Make sure that you are practicing and fully applying yourself for these skills. And then next class, we're going to be getting into the statistics part of it. Okay, so let us know if you've got questions. Otherwise, good luck.